What happened? And go out of the room.
Paradise law of electromagnetic induction. Mutual induction finished, no?
Yes.
LR circuit
Series.
in middle. So what I should revise, Vishwanath?
Yes.
Yesterday means self-induction, no? Coefficient of self-inductance. No? Yesterday, what you wrote, show me, right? Okay, self-induction, mutual inductance. Okay. Vishwanath, this LR circuit I am in middle. I will, if I finish that, no, generator finished, you know, total syllabus is over, then I will explain for you. Self-induction, everything. That will take half an hour. After that, I will explain once again. Okay. Okay, so I'm taking one self-inductor, I mean solenoid of coefficient of self-inductance, how much? L Henry. It is also having some internal resistance, how much? Capital R. And I connected to one battery of EMF, how much? E. After a long time I connected. After a long time connected, what will happen? Tell me. What is the current after t seconds? When current is growing. Yesterday I deduced one formula. When current is growing, what is the current after t seconds? E by R into 1 minus E power minus T by L by R. No? Say sir, no. This is a current after t seconds. What is this? Current after how many seconds? After t seconds. In after long time. After long time, substitute t value infinity. What is the current? Tell me. E by R into 1 minus e power minus infinity. What is the e power minus infinity meaning? 1 by e power infinity, na? Something power infinity means what? Infinity only. Something by infinity means what? 0. So e power minus infinity value how much? 0. So after a long time, current in the circuit how much? E by R. This kind of current is called steady state current. Steady state current. Means I can write one statement. After a very long time, how much current is flowing in the inductor or circuit? Respond. How much current is flowing? E by R. In such state, that inductor is called active inductor. What the name of that? Active inductor. Okay. Then hereafter, once the saturated current is flowing in the circuit, suddenly I will remove the battery. What I am doing? Suddenly I am removing the battery. What will happen? Tell me. This is an inductor. This is a resistor. Suddenly what I did? I removed the battery. When I removed the battery, as I told you, still inductor is active. Why I am telling inductor is active? It has some current, how much? E by capital R. Hereafter, this inductor is playing the role of battery. Understood? Means when time equal to 0, what is the current flowing in the circuit? E by R, na? Yes or no? After t seconds, if you see, after t seconds, the total energy stored in the inductor, total energy stored in the form of magnetic field lines. What is the role of the inductor? Tell me. The role of inductor, it is an instrument which stores energy in the form of magnetostatic lines, na? Magnetic field lines only, na? So which stores energy in the form of which lines? Magnetic field lines. What is the type of energy? Magnetostatic energy. How much energy stored in the inductor? U is equal to, remember, half Li square. Please kindly remember, in the next stage I will explain how it came. L is the coefficient of self-inductance. I is what here? Current flowing in the inductor. That is the total energy stored in the form of magnetostatic energy. Then if you switch on it, this magnetic energy entered into resistance in the form of heat energy. It is completely dissipating in the form of heat. Are you understanding? Again, I will repeat the statement. Initially, entire energy is stored in the form of what? Magnetic field lines or magnetostatic energy. I switched on. What will happen? This inductor will leak the energy. Where that energy will come? To the resistor. What is the role of the resistor? To dissipate the energy. I mean, to lose the energy in the form of heat. After some time, everything become empty. Total energy gone, na, in the form of heat energy. Yes or no? So let us see after t seconds. After how many seconds? After t seconds, this inductor is acting like a battery. Inductor is acting like a battery. And how current will flow? The high potential and low potential. How current will flow? Like this. This current is entering from high potential to low potential. Current is, this I is nothing but current at any time t seconds. Current at any time t seconds. I'll assume this is A to B, then this is B to A. I will use loop law. From A to B, B to A, I will use which law? Loop law. What is the loop law? Tell me. Sum of the voltage drop across two components, 0. I'm entering from A to B. A to B means how I am walking from high to low, means minus. What a voltage drop across inductor? L into di by dt. Then where to where I am entering? Low to high means plus, and I into capital R is equal to how much? 0. And minus L into how much? di by dt is equal to minus I into R. Minus minus cancels out. So I value I am sending this side. So L by I into di is equal to how much? R into dt. So this is a di is the decrement in the current in a very small time interval. I will integrate on either sides. L I will take it outside. L is constant, na? Integration of 1 by I into di. R also will take it outside. Integration of 1 into dt. Tell me what is the integration of 1 by I? Very good. Ln of I. When your observation started, what is the current in the circuit? E by R, na? Maximum current is flowing na initially. Initially, maximum current is flowing. Understood? After some time, I will assume current is I ampere. What integration of 1 into dt? T. When your observation started, what the time? 0. When your observation completed? After t seconds. Put upper limit first. So L into how much? Bracket start? Ln of I minus ln of E by R. R into, put the upper limit first. What will happen? T minus 0. But ln of A minus ln of B? Ln of A by B. So ln of A by B is equal to how much? RT by L. Understood? One small correction. Here, when current is going, na, EMF will induce is opposite direction. So here I have to put minus sign. Here one minus sign extra I have to put. Here also minus will come. 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 L already I took this side, na? So here minus RT by L. How to vanish ln? Tell me. Ln means base E, na? IR by E is equal to minus RT by L. To remove this ln, E power, I will do on either sides. Then ln and base E will cancels out. So I into R by E is equal to how much? E power minus RT by L. E by R send that side. So what are current after t seconds? E by R into E power minus RT by L. This is a very, very important equation. This is when current is decaying. What the name of this current is called? Decay of current. Decay of current. Why current will be decayed? There is no source, no? There is no battery, no? So current naturally decay. This E power minus RT by L is there, no? That is representing exponential decrement. Which one? Exponential decrement. So if you plot the graph, between current on y-axis, time on x-axis, initially when time equal to 0, what is the current here? Maximum, na? E by R. So it will keep on decreasing like this. Means after a long time, current become how much? 0. Is my point clear? So how will you define this time constant right now? Slightly I can write time constant equal to ratio of coefficient of self-inductance by resistance is called time constant. Time constant. Put the time constant value here. So current equal to how much? E by R into E power minus R by L into T value how much? L by R. LL cancels out, RR cancels out. What is the current equal to? E by R into E power minus 1. So total current equal to how much? E by R into 1 by E. E value how much? 2.71. Substitute here. So current equal to E by R into 1 by 2.7. 1 by 2.7 is nothing but 0.337 and into E by R. Means you can define time constant, the time taken to acquire 37% of the maximum current when current is decaying is called time constant. How will you define the time constant? How will you define time constant? Time constant, tau is defined as time taken to reduce to how much percentage? 37% of maximum current. What is maximum current? E by R only, na? Maximum current maximum current when current is decaying. When current is what here? Decaying is called what here? Time constant. Kamalesh, good afternoon.
Good afternoon, sir.
What happened online?
Sir, headache, sir.
Headache. Okay, so at a glance, At a glance, I will recall while current is growing, growth of current. When current will grow, tell me. Respond, when current will grow. I will take one inductor and its internal resistance is capital R. I put a battery. So in this moment, current will grow, no? Correct or not? At any time t seconds, what is the current in the circuit? I is equal to how much? E by R into 1 minus e power minus t R by L. The current after t seconds. And what is the EMF induced across inductor? At the time of t seconds, what is the EMF induced across inductor? Tell me. Minus L into di by dt. I value substitute here. So minus L into d by dt of I value how much? E by R into 1 minus e power minus t R by L. Minus L into e by R into what differentiation of 1? 0. Minus d by dt of how much? E power minus t R by L. So EMF induced across inductor after t second how much? Minus L into E by R and minus into minus plus. For differentiation of E power minus t R by L and d by dt of how much? Minus t R by L. So EMF induced across inductor is L into E by R and into e power minus t R by L into minus R by L. I will take it outside and dt by dt value how much? 1. Say yes or no. So L by R cancels out. What is the EMF induced into e power minus t R by L? Capital E. This EMF is there, no? What about the EMF? I mean, voltage drop across resistor after t seconds? After t seconds, what a voltage drop across resistor formula? Current into resistance, no? What a current after t seconds? E by R into 1 minus e power minus t R by L and into capital R. RR cancels out. What a voltage drop across resistance? E into 1 minus e power minus t R by L. This is a complete analysis of the growth of current. Now, reverse we'll see. Reverse means what? Decay of current. When current is decayed, tell me. Respond. When current is decayed in the circuit, if you remove the battery, correct or not? So only inductor of self-inductance L is there and resistance is capital R is there. I put a removed cell. What is the current after t seconds? Tell me. After t seconds, current equal to how much? E by R into e power minus RT by L. Understood? This is the current after t seconds. Now tell me what is the voltage drop across inductor after t seconds? What is the formula? Voltage drop across inductor equal to minus L into di by dt. I value substitute here. So minus L into d by dt of I value how much? E by R into e power minus RT by L. E by R I will take it outside. And what is d by dt of e power minus RT by L? Voltage drop across inductor equal to minus L into E by R. What differentiation of e power minus RT by L? E power minus RT by L and d by dt of how much? Minus RT by L. Huh?
Minus E power.
I differentiated Vishwanath, e power. I wrote this. E power x differentiation e power x only. No? E power minus x is e power minus x. So second time I am differentiating. No? What you are expecting negative sign, it will come. Okay. So minus L into E by R and into e power minus RT by L minus R by L, I will take it outside, and dt by dt value how much? 1. Understood? What you expected minus R by L come here. Minus into minus plus na. RR cancels out, LL cancels out, dt dt cancels out. But a voltage drop across inductor after t seconds? Minus E into e power minus RT by L. But a voltage drop across resistor after t seconds? Current into R na. But a current after t seconds? E by R into e power minus RT by L and into R. RR cancels out. What a voltage drop across resistance? E into e power minus RT by L. Understood? Copy quickly. One problem I will give. Thevenin method I will explain. Okay, in your IIT, how questions will be asked, I will explain now. Very, very powerful method, Thevenin method. Which method? Thevenin method. See, for example, this one inductance of 10 millihenry and connected to one cell of EMF 10 volt. This is one resistance of 10 ohm. Here one more battery is there, 5 volt. Here one more resistance 10 ohm is there. And this is one more battery 2 volt is there. This is one more resistance 10 ohm is there. Okay. Just now when time equal to 0, all switches are closed. All switches are closed. All switches are closed. Some problems will do. Find time constant. Find time constant. Will you try for 1 minute? Try for 1 minute. What a time constant formula? L by R. Na? L value we know. What is the coefficient of self-inductance? 10 into 10 power minus 3. And effective resistance I need to find. How to find effective resistance? In the place of inductor, you short it. Short it means remove the inductor and remove all the cells also. And draw only resistors like this. Understood? Effective resistance in the sense effective resistance between inductor only. Na? Effective resistance across terminals of inductor only. Na? That's what I removed the all cells. So this is 10 ohm and this is 10 ohm. This is 10 ohm. 10 ohm and 10 ohm in which combo? Series. And so 20 and 10 ohm in which combo? Parallel. But net resistance, tell me. R1 R2 by R1 plus R2. No? It's 20 into 10 divided by 20 plus 10. So 200 whole divided by 30. 0 cancels out. So 20 by 3 ohm. So 10 into 10 power minus 3 means what? 10 power minus 2 divided by, what is the effective resistance? 20 by 3. Correct or not? So 3 by 20 into 10 power minus 2 second is your answer. 10 if you 10 upside 1.5 into 10 power minus 3 second means 1.5 millisecond is your answer. Understood or not understood? Next question. Find Thevenin EMF. Find Thevenin EMF. Thevenin EMF or net EMF across inductor. Across inductor. Net resistance or this is Thevenin resistance. What is another name? R effective is also called what here? Thevenin is the name of scientist. This technique is denoted by, represented by this guy only. So effective resistance or Thevenin resistance also you can call. Now I will explain net EMF across inductor or Thevenin EMF. This method is important. You listen very carefully. After that, one problem I will give, you have to do it. Are you ready? Okay, so inductor as usually you short it. Short it means you remove and cells will be there 10 volt. And this is what? 10 ohm. This is what? 5 volt. This is 10 ohm. 10 ohm plus 10 ohm, how much? 20 ohm. Na? So directly I am writing 20 ohm and this is what here? 2 volt. Voltage drop across A and B is only called Thevenin EMF. Remember that point. Voltage drop across A and B is called what? Thevenin EMF or Thevenin voltage. Thevenin voltage. Now in this open circuit, here no current will flow, no? If it is an open circuit or broken circuit, then how current will flow? Current will flow like this only, na? Please say yes or no. Let's say how much current? I ampere. What is the current equal to? This 5 volt and 2 volt, it will be like this only, na? They connected. If you put them closer, you connected them like this only, na? Means net EMF how much? 5 minus 2, 3 only, na? The reverse series combination. Series means what? This is series. Means 5 volt plus 2 volt is 7 volt. But this is called which series? Reverse series. But net EMF equal to 5 minus 2, 3 volt. Na? So how much current going? Net EMF by net resistance. But net EMF 5 minus 2 means 3. Net resistance how much? 10 plus 20, 30. No? 3 ones are 3 tens are. So 0.1 ampere. How much current is going? 0.1 ampere.
The resistance are parallel.
Not parallel. Same current is flowing, na? When same current is flowing in the two resistors, those two resistors are in which combo? Series only. Understood or not understood? Okay. Now, what I am saying, this is A and this is B. This is 10 volt. This is 10 ohm. This is what here? 5 volt. And what is this? 20 ohm. And what is this? 2 volt. How current is flowing? Like this only, na? I want to find potential difference between A and B. Correct or not? How the current is flowing from high potential to low potential, high potential to low potential, high to low, but here low to high. Understood? This is A, this is C, and this is D. How I should walk from A to C, C to D, then D to B. I'll write potential at A how much? VA. Then A to C I am walking. When I am walking from A to C, low potential to high potential I am walking. Na? Potential will increase. So how much potential? I into 10. Na? I value how much? 0.1 into 10. Then I am walking from high potential to low potential. Says or no? High potential to low potential means what? Minus 5. Next I am walking from D to B. Means low to high. Na? Means plus 10 equal to VB. Says or no? So VA plus 0.1 into 10 how much? 1 minus 5 plus 10 equal to VB. So VA 1 minus 5 means what? Minus 4. 10 minus 4 means what? 6 na? Says or no? So VA minus VB value how much? Minus 6 volt. I mean potential difference across battery how much? 6 volt only na? That is called Thevenin EMF. I hope you understood very well. Now, how will you simplify the circuit? Tell me. How will you simplify the circuit? Inductance of 10 millihenry. What net resistance? What is the net resistance respond? 20 only na? Is a yes or no? 20 ohm only na? And what is net EMF? Just now I found 6 volt only na? Like that anything now you can answer. What a current after two time constants formula? E by R into 1 minus e power minus t by tau. After two time constant, I asked you. What is after two time constant? 2 tau. Substitute here. E value how much? 6 by 20 and into 1 minus e power minus t by tau. Net resistance is 20 by 3. Where? Okay, sorry. Correct. He was correct. So 20 by 3. Yes. Here also 3 will go to upside. No? Very good. Tau cancels. No? So 2 3s are 2 10s are. 3 3s are 9 by 10 means what? 0.9 into 1 minus e power minus 2. Is the current after what second? 2 time constant. Okay. Shall I give one practice problem? Will you try? Copy this first, then you try. Or no? Work out this problem. Find time constant. One by one, I will ask the question. Try. Find time constants. Quickly. Hmm.
3 into 10 power minus 3 seconds.
3 into
10 power minus 3 seconds.
10 power minus 3 seconds. Okay. What is the time constant formula? L by capital R. Na? L value how much? 5 into 10 power minus 3. And what about resistance? You have to short the inductor. Means to remove the cells also. So this is 5 ohm. You have to short the inductor. What is this? 5 ohm. And you have to remove the cell also. This is 5 ohm. Now this 5 ohm and this 5 ohm in which combo? Parallel, no? So 5 by 2 means 2.5 ohm. Understood? If you simplify this, this is 5 ohm. This is what here? 2.5 ohm. But net resistance 5 plus 2.5 is 7.5 ohm. No? Correct or not? So net resistance is 7.5 ohm. So 5 into 10 power minus 3 divided by 7.5 means what? 75 by 10. 5 ones are 5, ones are 5, 5s are 5, 3s are 5, 2s are. So 2 by 3 into how much? 10 power minus 3 seconds is a time constant. Understood? Now, next concept is last one, AC generator. AC generator. This is a AC generator is nothing but the instrument which will convert mechanical energy into electrical energy. Mechanical energy into which energy? Electrical energy is called as AC generator. So for example, if you see the description, there is one flat north pole, there is one flat south pole also there, and in between them, what is the uniform magnetic field? V Tesla is there. Understood? Within the two poles, one rectangular coil is placed like this. This rectangular coil is placed on the rotor. Rotor in the sense freely it can rotate about this axis of rotation. Understood or not understood? And at any particular instant, if you see the rectangular coil, this is the aerial vector, and this is the magnetic field vector. I mean external magnetic field. What is the angle between them? Some angle theta is there. So when it is started rotating, on the rotate, at the end of the rotate, one turbine is connected. Turbine means when water is falling on the turbine, turbine will rotate. As the turbine rotate, what will happen? This coil also rotate. When the coil is rotating, what will happen? Magnetic flux linked with the coil is changing with respect to time. As magnetic flux is changing, what will happen? EMF induced. As a result, some current also induced. That current we are using in our domestic purpose for running AC, TV, etc. This is a process of conversion from which energy to which energy? Mechanical energy to electrical energy. So as a result, this coil is rotating with some angular speed omega. What is the angular displacement after t seconds? Angular velocity into time t. Understood? So at this moment, what is the flux passing through the coil? B into A into cosine of theta. Theta is nothing but what here? Product of angular velocity into time taken. So substitute here. So what a total flux passing through this coil? B into A into cosine of omega into t. If n number of turns are there, so you must multiply with the n times also. This is the magnetic flux through the coil at any what time? Through the coil after t seconds. After t seconds of time. Then what is the EMF induced in the coil? EMF induced in the coil. EMF induced in the coil. How will you tell EMF induced in the coil? Minus change in flux by change in time taken. According to Faraday's law of electromagnetic induction. Flux you substitute here. So minus d by dt. Flux value how much? N into BA into cosine of omega into t. NBA I will take it outside. So minus NBA and d by dt of how much? Cosine omega t. So minus n into b into a. For differentiation of cosine minus sine omega t. And again you have to differentiate with respect to omega t. So what is EMF induced? Plus NBA into sine omega t. Omega I will write outside and dt by dt. dt dt cancels out. So what is EMF induced? NBA into omega into how much? Sine of omega t. This is the EMF induced after what time? T seconds. This is nothing but maximum EMF induced. Maximum EMF induced. What is another name also? Peak EMF induced. Peak EMF induced. How many? Come. Peak EMF induced how much? N into BA into omega. 2 minutes, friends. You copy then. Tell. A person takes how many seconds? T1 seconds to T1 seconds on a stationary escalator to cover some distance. Let's say the distance covered is how much? L meter.
Yes.
On a stationary escalator. How much time taken?
T1 seconds.
T1 seconds. Means T1 is nothing but distance traveled divided by velocity of the person.
Yes.
I'll keep aside equation number 1. Now a person takes t2 seconds in moving a escalator to cover some distance by same velocity. Person takes how many seconds? t2 seconds to cover same distance by same velocity. Person takes t2 seconds in a moving escalator to cover same distance by same velocity. So he is walking.
Yes, sir.
So that is distance traveled is nothing but what is the velocity of that person? Person takes t2 seconds in a moving escalator to cover. So in the second case, escalator is going and he is also walking.
Yes.
It will take less time. No?
Yes, sir.
Less time means more speed. The velocity of the person is nothing but what? On this
Needs more velocity, sir.
less means it should be more. No?
Yes, sir.
Means velocity of the escalator plus velocity of the man with respect to escalator. This is the equation number 2. Time reduced now. He's walking on the escalator. Reduce means
Velocity of light with respect to speed, sir. If velocity of ground is not good.
this total velocity of man only. Velocity of the man with respect to escalator how much? Velocity of man escalator, no? VA to this side. So VE plus VM.
Yes, sir.
And the third question, if the third statement is the person rests on escalator, when time, what time taken by him to cover the same distance? We'll assume when he simply stand in the L by velocity of the escalator. Okay. So this T3 you have to express in terms of T1 and T2. No?
Yes, sir.
So first one T1 equal to how much? L by velocity of the person. T2 equal to how much? L by velocity of escalator plus velocity of man with respect to escalator. T3 value how much? L by VE. So L by VE means T3 you have to express in terms of this. So this value I will take T2 equal to 1 by VE by L plus velocity of the man with respect to escalator by L. No?
Yes.
VE by L is nothing but 1 by T3. No?
Yes.
1 by T3 plus what is the VME by L? It is not given.
Yes.
Person takes T1 seconds on a stationary escalator. So why it can't be ME by L? Means 1 by T1. Stationary escalator means velocity of the man with respect to escalator again.
Yes, sir.
So if you take T2 equal to 1 by T3 T1, no? We want T3 only, no?
Yes, sir.
This I will take this side 1 by T3 plus 1 by T1 equal to how much? 1 by T2. This value take this side 1 by T3 equal to how much? 1 by T2 minus 1 by T1. So 1 by T3 how much? Take the sum T1 T2 by T1 minus T2. So T3 value how much? T1 T2 by T1 minus T2 value.
Yes, sir.
Students, are you alive? Dead? This guy gone. So what is the peak value of the EMF induced? N into B into A into omega. Tablet. Huh? Iodex. You have? I don't know what is headache till now. Who will use Iodex? I think zoology madam is there. Na? She might be having all these things. After break, you come to staff room. I will ask her. What the current? What the EMF after t seconds? Peak EMF into sine of omega t. What the current after t seconds? EMF induced by resistance. So substitute here. What is the current equal to? E naught into sine of omega t divided by capital R. You won't sleep well, Vishwanath? How many hours you will sleep? 6 hours. So E naught by R, that is the current induced in the AC generator. I think chapter over. Right? Now you asked yesterday topics. No? Chapter over. For him once I will revise yesterday topics. What are the topics? Self-induction. In the name only it is there. Self-induction meaning if you take any one current carrying solenoid. What is this? Current carrying solenoid. Some original current I ampere is flowing. Here I is changing with time. What is the current I? Keep on changing with time. As current is changing, you know, every current carrying solenoid acting like a bar magnet, no? So magnetic field lines, I mean magnetic flux linked with the coil also changing with time. I'll write down that point. If original current is changing with time, if original current is changing with the time, automatically what will happen? Tell me. Magnetic flux linked with the coil also changing, na? Magnetic flux linked with coil also changing. Say yes or no? As magnetic flux is associated with the coil changing means what? Induction taking place, EMF also induces. Already you applied one battery. Now additionally, induced EMF also generated. Already original current is also flowing. Additionally, induced current also will flow. That is the concept of self-induction. So I can write one statement. Flux passing through the coil is proportional to current. To give a perfect equation format, I have to keep is equal to symbol and I have to write L and into I. So what is the coefficient of self-inductance equal to? Total flux passing through the solenoid by total current. How the coefficient of self-inductance is measured? Flux is measured in Weber, current is measured in ampere. When 1 ampere of current is flowing, if one magnetic field line passing through the solenoid, then that coefficient of self-inductance is called Henry. That is denoted, that is measured with what? Henry. Some self-inductions, how to find, I will explain. This is one solenoid. What is this? One long solenoid. Turn density small n. Total number of turns how much? Capital N. But length of the solenoid? Small l. How to find its coefficient of self-inductance? L equal to total flux by total current. But total flux, total number of turns into B into A and divide by I. Correct or wrong? But a magnetic field due to current carrying solenoid at any point inside, mu naught N into I and into area of cross section by current. I cancels out. You know, turn density equal to how much? N by L. So total number of turns how much? N into small l. Substitute here. So what are the coefficient of self-inductance? N into L and into mu naught into N into capital A. So what are the coefficient of self-inductance? Mu naught N square L into A. You have to remember at your fingertips. Understood? Huh? One more thing. I will take a very smaller coil of radius capital R. Find its coefficient of self-inductance. What is the formula? Tell me. L equal to pi by I. Pi value how much? Magnetic field into area of the circular cross section into I by I. The magnetic field due to circular coil at its center, mu naught I by 2 into R into what area of the circular cross section? Pi R square by I. I ampere cancel, RR cancels out. What is the coefficient of self-inductance? Mu naught pi into R by 2. This is the coefficient of self-inductance. One more thing, I will take a square coil of length A meter, A meter, A meter, and A meter. Find its coefficient of self-inductance. What a formula here also? Total flux by I. But a flux is nothing but B into area. Area value how much? A square by current. Magnetic field due to first segment, second segment, third segment, and fourth segment. Na? So you can write 4 into magnetic field due to each finite segment and into A square by I. What is the magnetic field due to each finite segment? Tell me. What is the formula for magnetic field due to each finite segment? Mu naught by 4 pi into current by perpendicular distance how much? A by 2 and into how much? Sin 45 plus sin 45 means 1 by root 2 plus 1 by root 2. So mu naught 2i by 4 phi into A 1 by root 2 plus 1 by root 2 2 by root 2. So this is a magnetic field due to each finite segment. So substitute what I can write mu naught 4 into I divided by 4 pi A into root 2 and into A square by I. I cancels out. A cancels out. 4 cancels out. So what is the coefficient of self-inductance? Mu naught into A into 4 divided by pi root 2. That is the method to calculate the self-induction factors. Understood? Self-induction over what's up next? Mutual induction. Now mutual induction or mutual inductance, that is denoted with what symbol? Capital M. In the name only it is there. What is the meaning of the mutual inductance? Two coils must present. For example, I will take one long solenoid, coil number 1. Its turn density small n1, number of turns n1, length is L, area of cross section A1. And coaxially, one more solenoid I place like this. That is second coil. Here for second coil, turn density N2, number of turns N2, length is L and area of cross section A2. Understood or not understood? If coil is flowing in the first coil and it will produce some magnetic flux, that magnetic flux also passing through second coil. As you change this current I1, magnetic flux passing through second coil also changing with time, na? Please say yes or no. So I can write that statement. Flux passing through second coil is directly proportional to current in first coil. That leads to mutual induction. So to give a perfect equation format, what I can write, pi 2 equal to m into I1. What is the coefficient of mutual induction? Pi 2 divided by I1. What a magnetic flux passing through second coil? Number of turns N2 into magnetic field due to first coil into area of the second coil divided by current in first coil. But a magnetic field due to first coil at any point inside it, mu naught N1 into I1 and into A2 by I1. I1 cancels out. So what is the coefficient of mutual induction? Mu naught N1 N2 into A2. It's the coefficient of mutual induction. Okay. Have a break. Any doubts, come tomorrow or day after tomorrow. Okay. Thank you, students. Bye. Have a break.